Okay, so let's go ahead now and we'll get started here talking about our topic about now anyone can do AI. So let me introduce myself here. My name's Tim Fox, and I'm here as part of Elephant Scale. So Elephant Scale is a company which is involved in doing consulting and training on the areas of topics around big data, data science, and of course AI. And in fact, a lot of what we're talking about here related to AI is really kind of at the nexus of what, kind of we've been talking about big data and about data science, because one of the revolutions we're seeing now in AI is the fact that we're able to train models on very large data sets. So, okay. All right. So why do we say that anyone can do AI? Well, so AI's been traditionally kind of the domain of experts, right? So people that have PhDs in the field, people who have a strong background in maths and stats, et cetera. And a lot of the earlier versions of AI software that we use kind of reinforces this perception. So there's very little high-level help for the novice. Thousands of parameters that has to be tuned by hand. All of which kind of, many of which, kind of traditionally use kind of like Greek letters like alpha, gamma, beta, et cetera. So, so there's lots of ways that a beginner can go wrong. And so a lot of beginners kind of come to the field and kind of shake their heads and say, oh my, there's just too much math here. Now, unfortunately, or fortunately, depending on what your background is, there's the fact that math is involved in AI is somewhat inescapable, right? So, but there is kind of next generation of software available that allows us to work at higher levels, but it still end up being kind of productive in the area. Now, we're going to be looking at TensorFlow. And TensorFlow is the most popular we'll talk about this in a minute, but the most popular software for AI by a big margin. And TensorFlow is actually just now releasing the version 2.0. It's actually in the release candidate status as of this month. It does have a great deal of help in order to make AI a lot more accessible for mere mortals. Okay, so let's talk a little bit about TensorFlow. So now Google is the company that originally created TensorFlow. And Google they've described their core competency as a company is AI. They consider themselves an AI company. Yes, of course, I mean, we think of Google with search and we think of them with Gmail and with all these other things that they offer. But really what they see themselves as a company that is making AI accessible to users. Now, TensorFlow as a framework was open sourced by Google back in 2015. So now it really very quickly gained popularity. It had a good design, clean design, flexible, scalable, and also had a huge community. And of course, Google, having a big push behind it, is naturally a big part of that. Now, Google has given away an engineering effort that took them years to do. So why would Google do that? In the process, they're also enabling their competitors, the Apples, Microsofts, Facebooks, et cetera, of the world, to kind of use their AI products as well, right? So why are they doing that? Well, of course, Google wants to make their version of AI as kind of the standard. They want to see TensorFlow as the AI software, right? And so given the fact that no matter what happens, Google is going to have a lot of input into the open source TensorFlow project, that gives Google an advantage. So that's why they're doing this. However, you and I can benefit from this because we can end up using TensorFlow, which is the same AI software that Google themselves is using, and of course, in much of the world. And in fact, if we look at this chart of popularity here, So actually, you may have a little bit of trouble seeing the chart depending on the resolution of your screen, but you can see here that this green line here represents the overall popularity in terms of the TensorFlow framework as compared to other similar frameworks like scikit-learn in Python, MXNet, Theano, Torch, Caffe, etc. These are other AI frameworks out there, and they're all good in their own way. But at least in terms of popularity, there's no denying that TensorFlow is by far the most popular. And actually, there's a big spike in job postings, right? So as you can see, job postings that ask for the word TensorFlow all of a sudden kind of came over nowhere to get a huge spike. So now TensorFlow runs on all major platforms like Windows, Mac, Linux, and also on mobile devices, Android, iOS, etc. We can also run it in browser, tensorflow.js. The core of TensorFlow is written in C++. So that gives us a very efficient implementation. Now, we typically don't do our coding in Python in C++, however. The wrapper is in Python language. And Python language is very easy to use. Many of you are probably already familiar with it. And however, there is some support for other languages too, which is improving. Java, Go, R language, etc. And there are also a lot of other higher level APIs that are built on top of TensorFlow, Keras and PrettyTensor, etc. And in fact, Keras, we're going to be talking quite a lot more because that's become very important. It also has a nice UI called TensorBoard that enables us to visualize graphs and learning process. And there's a great community out there. Okay, so if we look at the versions of TensorFlow, the thing that's kind of prompting this webinar here is this last one here, 2.0 RC, which is been released in, now this is a release candidate, which means it's not yet the stable version, but we're very, very close. And so that was released this month. So now, you know, we're at release candidate status. Within a month or two, you know, of course, it's not known for sure, but very shortly, you know, 2.0 will be upon us, and that will be the stable TensorFlow version. Now, TensorFlow 2 is a big shift. And so there's a lot of aspects of TensorFlow that this is really affecting. Okay, so let's talk about ways that that is affecting this. One thing is that how we read and pre-process data. So now, this is something that we kind of a lot of times ignore when we talk about AI, but it's hugely important. Basically, what we got to do is we got to take our data. That's usually going to be in, you know, database tables, pandas, data frames, and we got to get that ready for it to go into TensorFlow to make AI models. So originally, TensorFlow didn't really help you with that. You had to write code yourself in order to format and process the data. However, in TensorFlow 2.0, the tf.data namespace has been significantly expanded. It actually did exist in 1.0, but it's significantly expanded, allowing us to do a lot of things around reading and pre-processing data and getting that there. So that's a big change. Another thing is TensorFlow Hub. Now, TensorFlow Hub is a lot like GitHub or Docker Hub, right? So if you're familiar with those, basically that allows ways for open source, non-proprietary models, AI models to be shared, right? So now there's, of course, been in the past lots of different places where you could download different kinds of other people's work. But again, one of the things that we've seen in other areas, like with Docker or with GitHub, we've seen like having a single place in order to manage a lot of kind of open, freely available work has been really helpful in doing collaborative development. So Google is introducing TensorFlow Hub or TF Hub, which is kind of their answer to this. And so that's kind of very much kind of just came out. So far it hasn't gotten a lot of use yet. But what you're going to see more and more, and this is one way that, as we said, mere mortals can use AI, is that you don't have to start from scratch. You can take work that's already been done there on TensorFlow Hub and then just build on top of that for your application. Now, also, as we see here, the older TensorFlow AIs were mostly very low level. And now in TensorFlow 2, we're moving to the Keras API. In addition to that, we're also moving to pre-made estimators. So these are the high-level TensorFlow API, TF Keras, the TF estimator, and these are designed for high-level use. Especially the estimators, in fact, are designed basically to be used at very high levels. So in other words, designed in fact, basically wrapping up all the functionality. Whereas TF.Keras is designed to be both easy to use as well as very functional for doing lots of different things within AI. The older TensorFlow APIs are now referred to as the low-level APIs, and those going forward are not going to be used very much because they're very difficult to use, particularly for beginners. And also, there's really very little need anymore because the Keras API has now basically replaced those for all but the most expert users. Also, we have now the ability to have a distribution strategy, which now, in the past, if you wanted to take your code and run it on a CPU, you could do that. If you want to run on a GPU or TPU, often you would have to kind of refactor your code in order to optimize it for those platforms. Now, we'll talk about this a little bit later. GPU and TPU are extremely important because they just run so much faster than CPU. But the fact that we can more easily write code, that we can move from CPU to GPU to TPU, that's really important. Okay. Now, we also have Saved Model. Saved Model is a new file format that TensorFlow is now using for, as it says, saving our models. And so it has a lot of updates. And one of the reasons why we have that is we want to be able to use that Saved Model format in many different areas. So, for example, in TensorFlow Serving. So this is, for example, let's say you have an AI model that you want to build in your cloud web application, right? So TensorFlow Serving has a server basically that you can use to deploy your model in cloud, right? Or on-prem on your in your application. So that's called TensorFlow Serving. TensorFlow Lite is going to be designed for your mobile apps and things like Raspberry Pi or Android or iOS and other things like that. So this is becoming really important. As a matter of fact, Apple is including what's called an NNP, neural network processor, that runs on iOS devices. That's in the latest iOS devices has this, and it's because they recognize that that these kinds of functionality is going to be really important for mobile apps. It already is, in matter of fact. So TensorFlow Lite is designed to run with your iOS, Android, or Raspberry Pi or other similar type of apps. And your Saved Model there, you can have that deployed in that. TensorFlow.js is going to be for like front-end JavaScript stuff. So, this is going to be really important too, because a lot of our modern web apps, we're going to want to have some AI available on the front end code, right? Running in JavaScript. And so that's another area where we're doing that. And then also for other languages, like, so for example, Python, of course, is the most important, but not everybody in the world programs in Python, right? So we have other languages that we're going to be able to deploy our code in there. So even if your company, say you're a Microsoft shop and you mostly program in C#, well, you probably aren't going to be training your models in that environment, but once you're going to be putting that into your app, it allows you to very easily be able to take your TensorFlow models and use them in that environment, right? So now, of course, one of the biggest things in TensorFlow, one of the reasons why it got so popular so quickly, is the fact that it runs really well on GPUs. When we talk about machine learning and AI, under the hood, it is a lot of math. Like we said, we can't really escape math. And the biggest area, which is lots and lots of matrix manipulation. Well, there's another application in which we do a lot of matrix manipulation too. Graphics, games, right? All of those polygons and everything's in your favorite games. If you're a gamer, that's all a bunch of matrix math. And so your GPUs that you use for your games or CAD or whatever you have software, these focus on a lot of that kind of algorithm, which means that when we get into AI and GPUs, it's a match made in heaven, right? So if you have a GPU on your machine, then that will help you run about 10 times faster your work for AI. So that's great. Now, gamers, I'm sorry to tell you that if you're going to be using TensorFlow on a GPU, it's going to take over, or actually, it doesn't have to, actually, but it really, the best way is it will end up taking over and consuming your GPU and all of the memory of the GPU. So you can't play your favorite games and you do your AI work at the same time, I'm sorry to say. But, you know, servers don't end up using graphics anyway. And workstations, you know, you can set it up so you can have two graphics cards, you know, one driving your display and the other one using for your AI work. So now, NVIDIA GPUs are actually, have been at least traditionally the best supported. And they use a proprietary library of NVIDIA called CUDA, which is designed for compute applications like supercomputing and other kinds of problems, and of course, AI. Now, one nice thing about this is that really all you got to do is just install TensorFlow GPU. And unlike the past, it pretty much will be able to run and use your NVIDIA card out of the box. Now, for data center use, according to NVIDIA's terms of service, you have to use their Tesla GPU line, very expensive actually. You know, NVIDIA also has a line of kind of designed for kind of workstation use called Quadro. Now, the GeForce line at NVIDIA, the gaming GPUs, actually work quite well. And so, for example, I usually use a GeForce GPU and works quite well, actually, for kind of individual users. Now, just in the most recent version of TensorFlow, they're also now supporting AMD GPUs using the OpenCL library, which is open source, unlike CUDA. But that support's a bit new, and it's not as fast yet, at least, as NVIDIA, but AMD's hardware is more affordable. And if those of you who are Apple fans, Apple and NVIDIA don't get along. So if you're using a Mac, then you probably, and your Mac has a GPU, which it may not, but if it does, then you're probably using an AMD GPU. So this is going to be really good because you're going to be able to use that on your Mac. Now, of course, you could always use a CPU version on your Mac regardless, right? But if you have an AMD accelerated GPU, then as of the very latest version, you can now do accelerated work. So, you know, Apple fans rejoice on that. Intel GPUs are not currently supported. In fact, Intel GPUs are mainly not really designed for you know, very serious use anyway. They tend to be more for, you know, integrated, you know, just for, you know, there, but it's not currently supported. Intel is actually working on some GPUs designed for AI, but they're not ready yet. So, okay. Now, GPUs are, of course, extremely important, and most of the work that I do in AI is actually on GPUs. Now, TPUs are Google's custom chip for AI. And in fact, if any of you are into Bitcoin mining or other kinds of cryptocurrency mining, you probably know that cryptocurrencies kind of move from the CPU to the GPU, which are still used a lot. But nowadays, actually, even GPUs are kind of not really suited to the problem. And now custom ASICs specifically designed for that application are kind of taking over now. ASIC stands for application-specific IC. Well, it only makes sense that in AI, we're seeing a new era of custom ASICs. And in fact, for TensorFlow, Google's created this called a TPU. Now, TPU stands for Tensor Processing Unit. Now, there's actually two very distinct use cases for TPUs. One is in training, and the second one is in inference, which is also known as an edge TPU. So that basically means you taking and using your model out in your production app. Now, for training TPU, unfortunately, it's only available in Google Cloud Platform for now. However, you can use it also in Google Colaboratory, which we'll talk about that in a minute. Now, the so-called edge TPU, Google actually has started now selling physical devices. So you can use those. These are also designed, these are mainly designed to be used kind of in things like IoT type devices, Raspberry Pis, robotics, other kinds of applications like that. Now, mobile is also using similar devices as well, and we're seeing that kind of thing there. So now, Now, Google Colaboratory is, probably many of you are familiar with this. This is a free hosted Jupyter notebook. There's another way, actually, when we're talking about now anyone can use AI, because, you know, getting your hands on a TPU if you don't work for Google is kind of hard, right? And so, it can provide you GPU and TPU workloads. In fact, it's the only place I know that you can get free GPU and TPU access at all. So this is really great for kind of light workloads and evaluation. Now, if you're a serious user and you like the idea of TPU, you probably want to upgrade to Google Cloud, which of course is going to cost money. But it is going to give better security and more guaranteed performance access, right? So, and actually, if you look at what the cost is of GPU and TPU on Google Cloud, you can see here. So you're, you know, for a kind of a latest gen GPU, you're going to pay about $1 an hour, and for one GPU, and for TPUs, you're looking at $4 to $8 an hour. So again, you know, that's doable if you kind of want to check it out, obviously. But you know, you can kind of add up over time if you're going to running that continuously. But anyway, that's what we have. Okay, so now let's talk about parallelization. So as you know, like being able to run a scalable AI is going to mean we're going to have to be parallelized. One thing that we know from the world of big data is the secret to running big data is big clusters, lots of parallelizations. Now, TensorFlow actually was one of the first AI frameworks that really focused on distributed parallelized execution. So an example of how this works is, let's say we have now TensorFlow uses a graph execution model. So here we kind of have a picture of like a very, very simple graph here, which is showing like a squared b plus 2, right? So a very simple one. Now, again, this is so trivial that we wouldn't need to parallelize it. But a big model probably would need to be parallelized. And in fact, TensorFlow kind of excels at this. So what you see here is we're showing here we have 2 GPUs. These could be 2 GPUs on the same system, or they could be 2 GPUs on 2 different boxes, right? But you can see here what we've done is we partitioned our graph model and put that on 2 separate GPUs. And then TensorFlow takes care transparently of the synchronization between this GPU and this GPU. So it's very common for serious users to have, like, say 3 or 4 GPUs on their box. And in fact, of course, it's, you know, for, for a larger setup, you might have many, many nodes, each of which has a bunch of GPUs, right? So, okay, and deep learning is the kind of AI that we're going to be focused on in TensorFlow. And deep learning just simply means a neural network that has more than one hidden layer. Okay. So now let's talk about high-level TensorFlow. Now the thing about the base level TensorFlow is very low level, and it's just more of an execution model. It doesn't automatically train our models. You can write code to do that. You have to do that yourself with tensor transformations. Now TensorFlow, or at least the modern TensorFlow, has a multi-tiered API. So we have the execution engine. We also have low-level TensorFlow APIs in various languages. And then we also now have higher levels of abstractions on top of that, including mid-level API in which we define layers, data sets, metrics, etc. And finally, we have very high-level APIs, which is called the estimator API. Now, the estimator API has actually been packaged with TensorFlow as of 1.0 version. And it's designed to be familiar with scikit-learn users. So in order to make kind of one-line models and use together with the TensorFlow datasets API. So it's mainly used for general purpose ML rather than deep learning. But again, if you want to go ahead and use that, it has a lot of advantages as compared to something like scikit-learn, because it is going to be a lot more flexible and scalable than something like scikit-learn. So that's the TF Estimator API. Now, in TensorFlow 2.0, it strongly is encouraging us to use the tf.keras API. Now, a lot of you have probably heard of Keras before. It's actually an API that predates TensorFlow. Now, a lot of people are a little bit confused as to what Keras is. There is a package for Python called Keras, just called Keras. And it's normally we refer to that to differentiate it from tf.keras. We just call it keras.io. So that's because that's their website is keras.io. So keras.io, if project, they define an API that is designed to be used for TensorFlow, but also other deep learning frameworks like CNTK, Theano, or whatever, right? Now, one of the advantages of using Keras as an API is that one thing is fairly high level, right? So that helps us. Also, it means that whenever we learn how to use this API, it's not actually specific to TensorFlow. So for example, CNTK is a Microsoft-oriented framework. And so we can use the Keras API for that as well. Theano, for example, is another backend, which we can use for Keras.io. Now, what TensorFlow's done is they've taken the Keras API, but they've re-implemented it within TensorFlow. Now, that means there's a little bit of a duplication, right? So if you want to use the Keras API, you can use the Keras project, Keras.io project, and just use that. Or you can use tf.keras. Now, if you know for a fact you want to use TensorFlow, I recommend using tf.keras because it's actually much better optimized and therefore faster at running TensorFlow than Keras.io is. And in fact, TensorFlow has said their implementation of the Keras API is the API that they want people to use going forward. The estimator API that I just mentioned is also supported still and is still used, but for most users are saying this is the APIs you should use. And they're also saying, except for kind of some expert tweaks and stuff, you shouldn't really need to use the low-level API that we traditionally use in TensorFlow 1.0 much anymore. The TensorFlow Keras API should really be able to allow you to do everything you need to do. And we talked about this big shift here, the TensorFlow 2.0, and Keras. The move to tf.keras is one of the big things with that. Now, another thing that we're seeing in TensorFlow 2.0 is there's a feature which existed before, but now is a default. It's called eager execution. Now, what eager execution means is that it means it's going to be the default mode of execution in TensorFlow. Now, the thing about eager execution is if I describe it to you, you'd probably say, well, doesn't that how all code runs? Basically, eager execution means is that whenever you run a line of code, it runs and evaluates everything right then, and it doesn't wait. Well, you would probably imagine, like, well, why would you do it any other way? Well, actually, in TensorFlow 1.0, it actually would not evaluate things immediately. What it would do is it would build this thing called the session graph. And then it would make a session, and then when you were ready to run the session, you'd say session.run, and it would run. Now, that does have a lot of production type advantages, right? It allows TensorFlow to kind of, it's sort of make execution plans for the workload and be able to do that on the graph. But the problem is that when you have to run that, when you're kind of running in development mode, it makes it very difficult to develop that way because it's, it doesn't allow us to do things like setting breakpoints, stepping through code, etc. It's as if you had to run your software kind of in like the most optimized compiling way, and you had no way to change that, and that also meaning no way to do any debugging or anything like that. Well, so in TensorFlow 2.0, the eager execution mode is the default, and what that means is that whenever a line of code runs in Python, it executes at that time, and it doesn't wait. Now, that may not be the most efficient way to run a large workload in production, but again, it's great for development. And that's the default. And that makes TensorFlow just a lot easier to use because the whole session graph thing is, for beginners, is just usually completely mystified. And the reality is that graphs and sessions are an internal detail that beginners really don't need to worry about so much. Now, another thing that's been changed in TensorFlow 2.0 is is basic globals and garbage collection. So in TensorFlow 1.0, all the variables that you would define in TensorFlow were basically added to the global graph. And there was no garbage collection. So what that means is that it was very difficult, especially for beginners, to keep track of old variables because whenever you define a variable in TensorFlow, it's essentially there forever in the TensorFlow session graph. And unless you very specifically get rid of it, it's going to be always there. In fact, so if you see a lot of rookies, you look at their TensorFlow graphs, you'll end up seeing a lot of the same thing over and over and over again, because they don't know how to clean up after themselves. Well, the same thing's actually true in programming. I don't know if any of you remember C++ memory leaks, right? But again, rookie programmers there fallen into the same sort of pitfalls. Now, modern programming languages, now, of course, that's fine for a lot of low-level coding, right? But for modern programming languages like Python, regular Python, Java, C#, etc., they use garbage collection. So that means if you lose track of a reference to a variable, it just gets cleaned up, which is going to be generally what we want, right? So, so it means that you have to be a little bit more disciplined at setting up, references to your TensorFlow variables. But it also is just good modern kind of modular programming, right? Now, TensorFlow 1.0 also didn't really have functions. Now, of course, Python has functions, and one can write TensorFlow code with Python functions. But that makes it difficult for TensorFlow to optimize, and it also makes it very difficult to share with other models. So what TensorFlow 2.0 does is allows us to define functions at the TensorFlow graph level. So there's an annotation in Python called tf.function that we can use now. And the way I look at it is it's kind of like a SQL sort procedure. So in other words, you can of course always write, even in database code, you can always write, so kind of some code in your programming language of choice that is that does some database operations. But there are a lot of advantages to be able to define a SQL sort procedure where you have kind of a block of access that you want to do, and then be able to encapsulate that and then reuse it. It makes it much easier and more efficient to use that and reuse it. And what it means is that we can embed common functionality at the TensorFlow level. In version 1.0, a lot of common functionality, you end up just having to cut and paste a lot of the same stuff over and over and over again, because there really wasn't any efficient way to encapsulate it. And that also made it very difficult to share kind of commonly used stuff with other people, right? So a lot of sharing just meant like cutting and pasting off of somebody's blog post and pasting it in your code, right? But this allows it to share shared libraries and code, etc. Hang on for a second. Okay. Now, there's another feature called autograph. So remember, TensorFlow does have this execution graph. Now, Python loops like for loops, while loops, and so there, they, of course, traditionally are just loops only in Python. So they didn't really provide any way for us to iterate over TensorFlow code. However, autograph feature allows us to write for loops and while loops in Python that then allow dynamic placement of cells and layers and this kind of thing. So here's an example of some TensorFlow code. Basically, if you're not familiar with TensorFlow, it may make a lot of sense. But what I want to highlight here is we're iterating on this TensorFlow cell here, and we're putting it inside a for loop, a Python for loop. And so what that's going to do is that's going to take that, and it's going to allow us to be able to kind of dynamically then add more things to our TensorFlow model and use a kind of a Python way of doing that things rather than the alternative. So autograph basically is able to then take that Python code and then put that into TensorFlow. Now, as we said before, Keras is now the recommended API for all our work in TensorFlow. Keras API is stable. So unlike the TensorFlow core API, which has a lot of massive changes used in other frameworks too, it's also much easier to use in most cases. And we can also wrap any low-level TensorFlow code that we still need to do in Keras wrappers. But that's mostly for experts. And other TensorFlow APIs like TF Estimator are now actually just Keras layers. Now there's another thing called the Dataset API. The Dataset API is much expanded now, and it handles the data management side of things. Now, this is actually a very important part of data science. We often, in AI, we don't talk about it a lot because we kind of consider it just kind of busy work. But the Dataset API is very important because we have to be able to get our kind of wrangle our data together to do that. So this is definitely a recommended way now of handling structured data, or whenever you need to mix structured data with unstructured data in the same model. And before we leave today, I am going to show a effort at doing this. So the Dataset API is going to allow us to use very large data sets. So it actually, you know, pandas data frames in Python aren't really particularly good at handling very large data sets. In fact, we don't usually use pandas data frames for that. We usually use like other frameworks like Hadoop and Spark to handle large data sets and such. Now, the Dataset API may not be kind of allow us to do that at maybe Hadoop level, but nevertheless, it does allow us to use very large data sets, which may be, for example, too big to fit in memory, say, right? So the Dataset API allows us to do very large data sets, and then also, of course, distribute them across that. So, okay. So now let's talk about installing TensorFlow. Now, installing TensorFlow is actually now much easier than it used to be. As a matter of fact, at this point, it's pretty much just as easy as just saying pip install TensorFlow or conda install TensorFlow. Now, I also recommend installing Keras too, just because as you've seen, TensorFlow and the Keras are becoming so tightly connected that it's useful to have the Keras. Now, this is the Keras.io version, but still, it has a lot of useful utilities that are nice. So I recommend installing that. Now, if you have a GPU, then you need to install, it used to be actually very tricky setting that up, but no longer. Actually, at this point, all you have to do is just say TensorFlow-GPU, and it should set it all up, especially if you have an NVIDIA GPU, it should just happen automatically for you that way. Now, what if you want to install what I'm talking about, the latest and greatest 2.0? Well, so the way to do that is the current version is actually 2.0.0-RC0. So that means, so using pip, we can say, you know, TensorFlow equal 2.0.0-RC0. So that's what it's called. Now, Conda, like if you're using Anaconda, it doesn't support TensorFlow 2.0, and it's not going to until the release is official. So, but never, that's no problem. You can just use pip for that. Okay, so let's now look at, let me look at a kind of example of some TensorFlow 2.0 example here. So what I'm going to do is I'm going to focus on doing structured data. In other words, you know, kind of so let me just kind of show you what we have. Okay. Now this example, by the way, it's called featurecolumns.ipnb, and this actually is something that comes directly from TensorFlow, and in fact, it is available on TensorFlow.org website. So let me go ahead and show what we have here. So now this is actually running on Google Colab. So in fact, if you're interested in checking out Colab, then you can just search for Google Colab, and it is really great actually for beginners, right? So it's connected to your Gmail or Google account, whatever you have, and you can see here that you can just go ahead and create yourself a new Python notebook, and here you go. Now, one of the coolest things about Colab is the fact that you can change the runtime type from, in this case, none, which means CPU, to run to either GPU or TPU. So let's say I want to do a TPU workload. Okay, here I am. So, all right, now I just said import TensorFlow as TF, and away I go. So that's really cool. I think, so again, your company may not want you using your sensitive data or whatever on Google Colab, but nevertheless, it's a great tool for kind of evaluating that, right? Okay, so now what we're going to look at here is we're going to look at this is actually a data set, which is from the Cleveland Clinic Foundation on Heart Disease. So what we have here is we have several columns here, for example, which comes from a medical study on heart disease. So for example, we have the age, what's the age of the patient, what's the sex, what kind of chest pain is the person experiencing, We have some different things like the cholesterol, other kind of things here. I don't want to go into all these things, but you can see here what we have is we have some different types of data. We have some of this variable is some of this is numerical data, like the person's age, right? That's numerical. Other things are categorical, like the sex or other kinds of things, right? And then at the end of the day, we have the target. So the target here is, by the way, if you want to follow along, let me just give the link for everybody here. So I'm going to give you the link for this. This actually does come from the TensorFlow website, but let me just give a link here so you can follow along with this. Okay, so I'm going to go ahead and place this in the, hang on for a second. All right. Okay, so let me actually, let me do a chat here. Okay, if you check the chat window, I'm going to give a link here that you can use this to go ahead and follow along yourself. There'll be a link there to take that and put that in Colab yourself. Okay. Okay, so now your problem, whatever you're looking at for AI, might be very different than this, might be very similar to that. But you can see this is going to apply to a lot of different things. Like let's say, for example, you're trying to detect fraud, for example. You might have similar kinds of things. At the end of the day, your target would be whether it's fraud or not, right? So there's a lot of different things, right? So okay, so what we're going to be doing here is we're going to import TensorFlow and other libraries here. And you can see here what we're going to be doing is we're going to be using TensorFlow 2.0 because like I said, a lot of the features that I'm going to show here are going to be in available for TensorFlow 2.0. So by default, Colab is going to be giving you the stable version of TensorFlow, which is still 1.14. At least as of today, right? So, but what this lab is going to do is going to upgrade us to 2.0 to preview, and then that's what we're going to have. So, okay, so if you've ever done any kind of data analysis in Python, you probably are familiar with the concept of the pandas data frame, right? So here we have it. So first thing we're going to do is we're going to load this into a pandas data frame. Now, in a lot of cases in real life, if your data is probably too big to load into a pandas data frame. Pandas data frame is designed for kind of like dealing with like megabytes, like not gigabytes of data, right? Because the reason why that is that at least by default, it tends to load most things into RAM. And so, but in this case, our data set's relatively small. So we're not going to shy away from loading it into a pandas data frame here. Okay. Now, okay, so so now we have a pandas data frame. So we see this again. Each row here represents a patient. So 63-year-old, et cetera, et cetera, et cetera, right? And so then we have that. Now the target at the end of the day is whether or not they are diagnosed with heart disease. 0 being no, they did not have heart disease, and 1 meaning they did have heart disease, right? So, okay, so all right, so what we're going to do is we often do, if any of you are familiar with machine learning in general, we will, in this case, we break up our data set into training and validation and test. So that's what we're going to do here as well. So notice here we're going to take 193 for training and 49 for validation and 61 for test. Okay, so we are going to now create an input pipeline. Now remember I said before that one area that TensorFlow has changed quite a bit in 2.0 is its better support for kind of the front end pipeline of dealing, kind of getting and getting data. So what we're going to do is we're going to be taking that pandas data frame and we're going to convert it into a TensorFlow object called the dataset, which is actually in some ways very similar to the pandas data frame. So this little utility function here, in fact, is going to help us to do that. So what we're going to do is we're going to get and we're going to create TensorFlow datasets out of each of these things. So this function here basically converts the pandas data frames that we had before into TensorFlow data sets. Okay. So now what we're going to do is we're going to look at our variables, which we call our features. So we're looking at our feature here. This is age, sex, et cetera, et cetera, et cetera. These are all of our features. Now notice we do not have the target as one of our features, because that's because we're going to try to predict that, right? So these are going to be just the kind of the different, things like age, sex, all these things that are going to be the variables that we're going to use to try to make our prediction. And then we're going to have our targets. It's going to be whether or not the person had the heart disease or not. Okay. Now, what we're going to do here is we're going to use the TensorFlow 2 API. And one of the things we do there is we define this thing called the feature column. So the feature column is basically kind of like our schema. We're going to then specify what variables or columns in our data frame that we want to use in order to make our AI model, right? So what we're going to do is we're going to see, of course, there's different kinds of columns here. So now what we're going to do is we're going to look at some of the different columns. Now, some of the things like age are numeric columns. So those are the easiest to deal with. So we'll just take the data and we'll just make a feature column out of it, which is and what we're going to do is we're going to simply just pass in what we see. So for example, the first patient was 54, the second was 65, et cetera. Now, another kind of column we have is called a bucketized column, which basically means is that what we want to do is instead of taking the literal value, we're going to want to kind of divide it up into buckets, right? So, so the example like for age might be is like, let's say we have like age boundaries like 18 to 25, 25 to 30, 35 to 40, et cetera, right? So we're creating these different buckets. And what that's going to do is that's going to take our data and basically just create this, what we call one-hot encoding in the vector. And essentially what that's going to do is allow us to create kind of a bucketized version. So now, what about things like this column, I think it's thallium, is, again, which has fixed, normal, or reversible. So this is what we call a categorical column. So what do we do with that? Well, one way we can handle that is called, again, one-hot encoding, which is similar to what we did here. So since there's 3 possible values, what we'll do is we'll convert that into an array like this. In this case, 1, 0, 0 would represent the first element. So if it's fixed, then it's 1, 0, 0. If it's this one normal, then it'd be 0, 1, 0, et cetera. And so this is called one-hot encoding because whenever we convert it to this format, only one of these can be 1 and everything else is 0. So that's why we call it one-hot. So, okay. So that's how we can handle categorical columns, especially if the possible values is relatively small and known in advance. It has to be one of these 3 types. Now, what if we have very large numbers of possibilities? Like, let's say, for example, we were looking at something like where there might be hundreds or even thousands of different possible values, right? So, like maybe a zip code, for example. A zip code is a categorical data. It's not actually numeric, despite the fact that it looks like it's numeric, right? But it's a very, very large number of things. We couldn't really reasonably probably make something this for every single possible zip code, right? So what do we do with that? Well, what we can do is we can make an embedding column. So an embedding column basically means it's going to convert that into a series of numbers, basically. And so what that allows us to do is it allows us to represent a categorical data which might have literally thousands or even millions of different ones. And basically it's going to be kind of like a hashing mechanism where it will hash that to a series of numbers. And notice here the numbers is going to be a fixed size, right? So we don't have thousands and thousands and thousands of things here. In this case, it's fixed size. So that's called an embedding column. So it's pretty cool. Another hash-oriented way is called a hash bucket type column. And what that's for is generally that's used for cases where we have a fairly large, a fairly reasonably sized number of things, but we don't know for sure what they are in advance, right? So let's say we think there's approximately 10 different types, but it could be 11 or it could be 12, or maybe they could add some more. Then we can use this hash feature column, right? So now cross-feature columns here are used for situations where we might want to combine several different features together, like maybe like lat long together, right? We want to look at them together. So that's called a cross-feature column, right? Okay, So then what we'll do is we'll choose which columns we want to use. So we're specifying here are the columns that we want to use, this, 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 this. And then we're specifying in our feature columns, what kind of ways do we want to treat that? We have our numeric columns, our bucketized columns. So basically what we're going to do is we're going to treat age as a bucketized column. These ones here are going to be a vocabulary list categorical column. This one here is going to be an embedding column, and these are going to be cross columns. So now what we're going to do is we're going to use a Keras layer. So remember, like I said, we're strongly encouraged to use Keras. So basically when Keras, what we're going to have here is we're going to have a input layer. And so the input layer here is called dense features. And the dense part basically means is that we're going to store the data densely. So in other words, we're going to expect that of all of our features, that generally speaking, most if not all of our features are going to have a value, I'm sorry, most of all of our rows are going to have an entry for the features we're looking at for. There are other cases where we might use sparse features, maybe where we have large numbers of features, but maybe most of our data doesn't have data for those features, right? But in this case, dense features definitely works for us. So what we're going to do is we're going to define our Keras layer. So what we're going to do here is we're going to define this feature layer, which we're defining our features. And then we're going to define our neural network layers. Now, you may or may not be familiar with neural networks, right? And so if you're not familiar, then some of these terms may be confusing for you. But basically what we have here is we have two hidden layers. So that basically just means is that those are going to be where our neurons are going to get entered. And we're going to define those as size 128 and 128 each. So we basically got a layer of 128 neurons and a layer of another 128 neurons. And we're defining our activation here as ReLU. Again, if you're not familiar with neural networks, that may not make a lot of sense for you. But I want to point out here that, the way that we're able to do this in the Keras API is going to be fairly straightforward, right? So, we can define our hidden layers. We define the size and the activation here, although we don't have to do that. We could basically leave off activation and just allow defaults to go there. And then at the very end, we're going to be using an output layer, which is going to be of size 1. And so that's because our output here is going to be defining, in this case, whether or not the person has heart disease. So since it's this or this, we're going to be defining that as basically a single element, which is going to use sigmoid activation. Again, if you're not familiar with neural networks at all, that may be a little bit confusing, but what this is going to be is, this is going to basically define here, this is for a problem where I'm trying to classify it as either this or this, right? So what I'm going to do is I'm going to go ahead and use Keras here to go ahead and train my model. And that's what this fit method is going to do. I'm going to take my training data set and I'm going to run this for like 5 epochs. So let me go ahead and just run this now and see what happens. Okay, so I need to actually, I think, go back and call my feature layer first here. So hang on for a second. Okay. All right. All right, so now I'm going to go ahead and train that. So notice here, I ran through 5 epochs, right? So, okay, and at the end of the day, my validation accuracy was around 71% or so. Now, I could try to run for more epochs because that was actually pretty fast, right? I could try to run for 50 epochs or whatever. Now, epoch just means an iteration, right? So the more epochs I run, well, potentially, again, there is kind of some pitfalls there, but the more accuracy I might expect to see. And sure enough, in this case, you notice here that if I ran for 50 epochs, my training accuracy went up to 83%, or 84% actually. So again, I know that some of you are beginners and I don't want to get too deeply into some of the technical details, but the idea here is 84% accuracy. That means we were right 84% of the time for our training data, and for our validation data, we were right about 75% of the time. So, okay, so 75% of the time. Now, that's not bad. Potentially, we might want to try to improve accuracy by trying to think more carefully about what features I want to keep my model, et cetera. And there's a lot of things that I could do here. Probably if I ended up playing around with this and tweaking some things, I could probably get, in fact, this validation accuracy kind of closer to what I'm seeing here, maybe in the 85% or so. So it's definitely, worth playing around with. But the point is that my model now I have an AI model that, given somebody's age, somebody's sex, somebody's blood pressure, somebody's cholesterol, all those things, I can predict with 85% accuracy whether or not they're going to have heart disease or not. And you can imagine a lot of use cases for that, right? That can be useful. Not only that, actually, I can also, my output actually I can take and give some level of confidence. So how confident am I in my prediction, right? So I could take this and I could say, you know, we think you are probably likely to get heart disease, and we're like say 90% confident of that, right? So that can be very useful AI application for a lot of patients in this area. Okay, so the point of what I'm trying to do here actually is to try to illustrate some of the new features in TensorFlow 2.0, and to also kind of point out that although, again, you know, it's probably not a point where you can get away with not understanding anything about math or AI. Nevertheless, we're far long from a place where you have to have a PhD to become an AI practitioner. As a matter of fact, there's a lot of great resources out there, and especially with kind of the latest generation of libraries like TensorFlow 2.0, we're definitely at a place where right now where you can start getting AI as part of your development efforts and what you're doing. So, all right, so that's it from my side. Now, any questions from you? I'm eager to hear anything that you might have. So. So you may want to use a chat feature, by the way, if you have a question, just because with the number of participants we have, it might be easier to make sure that we all get the question and everything. So feel free to use the chat feature on Zoom for that if you have a question. Okay, yeah. Oh, yeah. I'm sorry about that. I think I didn't say. I think I sent it only to panelists. I'm sorry about that. Let me go ahead and share it to. Let me go here. Okay, let me send this here. There. Oh, sorry about that. I know that some of you are probably wanting to follow that along, and I'm so sorry I didn't get that. Yeah, I got a question, and I will actually pass in the PowerPoint. In fact, let me just go ahead and do that really quick. I'll take the PowerPoint, and I will. I'm going to. Yeah, I'm going to take that, and I'm going to export this, and I'll go ahead and. Yeah, in fact, I'll go ahead and get this available for all of you. Let's see. Let me see. I think what I'll do is I'll actually provide a link here, which will help you guys in terms of downloading that. Now, while I'm doing that, let me answer the next question, which is what would we recommend for a real beginner? Well, so I think obviously one of the things if you're an absolute beginner, I would recommend starting with is it's probably best to have some knowledge of kind of doing sort of work with data analysis, et cetera, in Python, right? So just because when you're starting with AI, the Python is kind of the language of choice. It's certainly not the only one, but it's probably the language of choice. And if you're trying to learn both Python and kind of working with data analytics and AI all at the same time, that could be kind of hard. So I think I would start out. So what I'm talking about is get generally familiar with using tools in Python, like say pandas, NumPy, et cetera, that kind of stack, right? And kind of get familiar with that. And you also learning some basic machine learning as opposed to kind of AI, just kind of basic machine learning, like using the scikit-learn package in Python is probably a helpful place to start, right? And there's a lot of good resources out there for learning that. Then I think at that point, then taking on sort of deep learning in AI becomes a lot more accessible. Also, there's a lot of good resources out there. So, for example, there's a lot of great videos. Probably a lot of you are familiar with Dr. Andrew Ng. Dr. Andrew Ng's, he's a professor from Stanford, has a lot of really good kind of video resources and other things out there to kind of help get you up to speed on some of the kind of fundamentals and theory side around around AI. So I think that's a good resource to use. In fact, there's many others, of course. Actually, if you're interested in a book, I could probably recommend, although unfortunately, the book is probably pretty out of date as far as the TensorFlow part goes. But of course, if anything published before like a month ago is probably out of date as far as TensorFlow is concerned. So, but it's a good book nevertheless. Let's see here. I'll get you a link for that book as well. So, okay, hang on. I'm actually in the process of uploading the slides here. So give me a second. Okay. Okay, let's see here. And I'm giving you guys this link for everybody. Okay. All right. So there's a link for the our PDF. Now, let me just go back to the chat here. Just make sure that we got that. Oh yeah, I was going to give you. So there's a text by Guéron. Let me actually get a. Let me get a link here, like an Amazon link. Or the, if you'd like looking for their. All right. So this is a good book, if maybe now a little bit out of date, although there is actually a version 2 coming out that is apparently not released yet. But I'm giving you the link for this here. Okay. It's by Guéron, and it's called Hands-On Machine Learning with Scikit-learn and TensorFlow. So good book. Again, the only thing is just that this one was published in 2017, and everything changes so fast. So that's but that's just going to be the true of any printed text that you're going to come into contact with. So. Okay, so any other questions? By the way, I guess another option as far as that is that at Elephant Scale, we do a lot of training. So mostly kind of corporate type training and that kind of thing. So if you have a team and you want to get up to speed in AI, we can certainly do either a virtual or on-site training for you guys as well. So yes. Okay. Anyway, appreciate everyone's kind attention. Hope you enjoyed it. So yeah. Okay, well, I'm going to sign off then. Thanks to everyone, and best of luck.